All right, first step for today is going over the homework from the textbook, which was questions 5 and 6. 6 is really hard, so don't freak out if you weren't getting it. This is why we're going over it. I know this is always one of the most challenging questions of the textbook in grade 6, actually, so don't panic if you were not, if you were struggling with that question. That's why we're going over it. Okay, so first of all, number 5, the pattern over here we're going to be using. We have to write the pattern rule that relates the number to the amount. Okay, so we're figuring out first of all what goes in the boxes. We're using our strategy over here for how much we're increasing by, which is 6 each time. So I know that's going to be one of my numbers. So I'm going to take a guess and think that it's going to be times by 6. So let's see. 0 times 6 is 0. How do I get to 5? I add 5. Okay, so I think it's going to be maybe plus 5. So 1 times 6 is 6, plus 5 is 11. Great. 2 times 6 is 12, plus 5 is 17. Super. So that's it. So the pattern rule is going to be, okay, remember we always have to say start at 0. Then we're going to increase by multiplying by 6, then adding 5. Okay, so these are the key things that are from the box each time, or from the machine. Okay, next is B. We have to write the expression. Okay, so if I have, this is my variable, I'm going to call my variable n. It's a little bit smaller. Okay. So if I had, so I know that my n is going to attach to the first number. So I'm going to have 6, and then I'm going to call it n, depending upon what the input value is. And then I'm going to do add 5. Okay, so that's my expression. If I wanted to do an equation, maybe I would have this, my amount, for example, I could call that a. So then I would just do something like this. My equation doesn't ask for this. I'm just showing you as extra. 6n plus 5 equals a, if my amount is my variable over here. Okay, but he doesn't ask you to do that. That was just kind of a little extra. Next, we'd have to write a story problem. So the one I gave you, I think, as our example yesterday was if you're entering a carnival or maybe fall festival, and it costs $5 to enter before you've gone on any rides, then it's going to cost an extra $6 for each ride that you go on. That could be an example. That's what I provided yesterday. Another example, let me think here, maybe, okay, I'm thinking about maybe yogurt or something, frozen yogurt. So if you bought, so I could say the cost of frozen yogurt is $5, and each topping costs $6. That could be an example of a story problem. Maybe I want to know how much does it cost for, I'm going to go more than 4, I'm going to say I want 8 toppings. Okay, that could be an example of a story problem that you wrote. So the key thing, as long as you have the two things, you should have the amount, which is the variable, the constant, which in this case, this does not change, right? That's going to remain the same all the time, which would be this one here. And then you also have to have the variable, which is the thing that is varying depending on how many times, or how many of the different toppings, or how many of the different numbers that you have. Okay, so that is the first question. And then the next question, let's see here. Okay, I'm just gonna add in another one. Okay, so, whoopsies. Okay, move you to here. Okay, now, so the next thing that we're going to do, this is honestly one of the hardest questions. Okay, so Skylar wants to adopt a killer whale through this adoption program. The yearly cost is $59. So that's how much they have to have in total. Skylar walks a neighbor's dog to raise money, and he gets $3 for each of the walks. Make a table to show the amount left to raise after this many walks. Okay, so You could do the table in either order that you want. I'm going to show it, okay, with number of walks here, and then amount to raise, dollars. Okay, so say that I'm going to show up here just to show this. I'm going to show an extra column of 0 walks. Okay, you don't have to do this because it only asks you to do 1 to 5 walks left. Okay, so if I didn't do any walks yet, how much does it cost? How much do I still have left to raise? Well, we have $59 left to raise because that's how much it costs. If I haven't done any work yet, I have to raise $59. If I've done 1 dog walk, or Skylar does 1 of the dog walks, then he earns $3. So we get to take off $3 from 59. So it's going to be 56. Then again, another walk, 2 walks is going to be 53. And then again, subtract 3 is going to be 50. And then we're going down, 47, and then it's going to be 44, okay? So there you go. That is our table. Now, it's going to get trickier because now what we need to do is figure out what is happening in this machine because they're asking us to write a pattern rule, right? Okay, so this is the hardest part because the pattern rule, normally we know, and I'm sure that we're probably going to attempt to do this, is we're thinking, okay, well, we know we have -3 over here. So I'm going to try doing times by 3. Okay, let's try. I'm going to go to the 1. So 1 times 3 is 3. How do I get from 3 to 56? Well, I could add 53. Okay, let's see if that works. Okay, but this is already fishy to me because if we're remembering earlier, usually, well, in all cases, if we go back and look, these numbers that are given in this story problem are going to be in somewhere in our machine. But the question is where? So I'm already thinking a red flag's going off in my problem solving head of thinking, oh, I don't like the fact I put 53 here. That does not make any sense to me. So I need to think of a different number that I can add in. Okay. So, so I know it's going to be, or at least I'm thinking a very strong possibility is going to be 59. Okay, so times 3, and then I get 3. What if I did minus over here 59? Okay, well, 3 times 3 is, I'm gonna erase this, yeah, okay, that worked well. 3 times 3 is 3, and then how do I get to 56? Minus 59. But that's weird because if I had 3 minus 59, that gives me a negative number, right? We have to have the larger number always first. So what if I did this? Woo! Okay. What if I did it as, oh geez. Okay, whatever. Blue. Okay, whatever. We're printing it's the right color. Okay, what if I did this? Minus 59, and then I did times by 3. But the thing is, my times by 3 is connected to the number of walks, right? That's connected. That's going to be my variable. That's going to be maybe my W. And I'm going to call that W over here. Okay, well, would that work? Let's just do a little bit of practice down here. So say that I had 59. I started with 59, and then I did 59 minus, it should be almost, like the minus should almost be in the middle here, right? Minus 3 times W for how many dog walks I did. Would that work? What if I replaced my W with one of the values? What if I replaced my W with, I'm just gonna try 2. Okay, let's see if that works. Let's see, okay. So 59, I'm just gonna write this over here. 59 minus 3 times 2. Okay, so that means I'm focusing right now on this one, right? Okay, so 3 times 2 is 6. 59 minus 6 is, woohoo, 53. Okay, and that matches up here, 53. Okay, so even though this is a little bit of a backwards way to find it, this is where we kind of just have to think logically about like what's happening in this story problem. And this is why this one was very, very challenging, because they ask for it in a bit of a backwards method. But if we think about this, okay, does this make sense? In a way it does. So the pattern rule, okay, so pattern rule would be start at 59, because that's what we're starting at in this case. Start at 59, and then we're going to decrease by, really what we're doing is multiplying by 3, then subtract from the multiply by 3, then subtract from 59. Okay, that would work. Yep, because we've multiplied by 3, then subtract, or it should actually be start at 59. Oh no, actually, sorry. It should be start at 59, decrease by subtracting by 59. Oh, this is really complicated wording. Decrease by subtracting 3 times, I guess we should even just write the number of walks. The number of walks from 59. Yeah, that is super awkward, but that does make sense. Start at 59, because that's how much money we're starting with. Decrease by subtracting 3 times the number of walks that we've done each day from 59. Yeah, that is it, which is kind of awkward. Or I guess we could say like subtracting 3 each time if we're just sort of talking only about the output. Okay, but that is, yeah, that's it. So don't worry about this one so much if you didn't get it for the pattern rule. The expression I would think that we should have a bit more success with, which is this one. Okay, so 59 minus 3 times W. Okay, next. Find the amount left to raise after 15 walks. Okay, so I'm just gonna erase this so I have a little bit more space. Okay. So basically what I'm doing for this one is my W has turned into 15. So I'm going to do 59 minus 3 times 15. So I'm going to solve, doing PEMDAS or BEDMAS, I'm going to solve this first. So 3 times 15 is 45, and then I'm going to do 59 minus 45. So 59 minus 45 is 14. Okay, so you have $14 left to raise. 14. Okay, and then so that's the answer for D. How many walks does it take? Will it take Skylar to raise enough money? Okay, so that one. Okay, well we know that if we've gotten to 15. It's not quite going to be enough. So this is where we can just do like the guess and check method. Okay. So, well, I guess, yeah, okay. So we know it's, okay, so I'm gonna try this again. 59 minus 3 times W, okay? Has to equal 0, because I don't wanna have any money left, right? So I have to figure what 3 times what minus 59 is going to get us 0. Okay, so I know it's going to be bigger than 15. Maybe it's going to be, why don't we try 20 as a number? Why don't we try that? We'll see how that one works. So 3 times 20 minus 59. Okay, so 3 times 20, so 3, that is 60. and then 59 minus 60, well, that gives us negative $1. So that means I have raised enough. I even have an extra dollar left over. So the answer is going to be 20, because if I did 19, it wouldn't be enough, right? 19, 3 times 19. If I use 19 instead, what is that? That's going to be 57. 59 minus 57 is 2. So I still have $2 left to raise, so that's not enough. So the answer should be 20. Okay, that is really, really, really tricky. You know what? I've actually never seen a question that is this hard on the PAT. So that's kind of cool. Okay, so hopefully that didn't really confuse you too much. But this is where I guess just like the problem solving and guess and check is going to come in most handy. Okay, well done. So that's it for this review. The next part is going to be explained in our lesson today, which is going to be linked. There's 2 parts. One part's going to be linked to solving your partner's question, and the other part is going